All right. So let's talk about 3.1, which is called the Fair Division Games. Now, that initial introduction at the top is like if I was to give everybody out here three oddly shaped objects and ask you to divide it evenly, what you'll notice is it's not going to have an axis of symmetry. These shapes aren't even, right? There's no way for you to actually divide this evenly. But you're going to do really the best that you can, and what you're going to understand is that every opinion you have, even though some of you may not think so, they're all going to be correct here. So here is kind of our elements for the fair division game. You can see them right here, right? Here's our elements of the fair division game. Now, I don't know what's going on. It's okay. So we've got the goods, the booty. This is S. These items will be divided, right? Example, physical objects, pie, land, or intangibles, just like, things like pirates, right? The booty, okay? Uh, the intangibles, are they rights? Are they obligations, right? It doesn't necessarily have to be something like mathematical. It doesn't necessarily have to be something, tangible. What about the intangibles, the things that you can't touch or see? These are our rights. These are our obligations. These are the things that we want, but necessarily can't, grasp. Our players, we'll call them P, just like in Unit 2 and Unit 1. Players P, they are the parties entitled to share goods. So individuals, groups, institutions, etc. These are all individuals, parties entitled to share the goods, the booty, whatever you want, the pie, the land, the rights, the obligations, all of that. The players are entitled to those. Then we've got the value system. Now, the value system is each player's internal ability to quantify, interesting word there, each player's internal ability to assign value, the goods, or any part of those said goods. Not every player will have the same value of that said given object. So if me and someone else had rights to a plot of land, I might have more than somebody else. For example, you and your siblings, or you and anybody that you might know, you might inherit 10 acres of land, right? Just using one of the tangible examples, physical objects. Yet in the will, it says that you have the rights to 5 acres, and somebody else has the right to 2.5, and somebody else has the right to the 1, until all 10 acres are distributed out. So, these, not all players will have the same value of that said piece of land, or that, piece of pie. If you got a pizza, who knows, right? The rights or the obligations. So, absolute terms, here's one for the value system. This is worth money. So absolute terms are worth money. Relative terms are worth a percentage of goods. So if I say, what's the absolute term of something, you're talking money value, right? You want money. We talk relative. Relative, mathematically speaking, is like a percentage, right? If you have a 10-acre plot of land, and your absolute term would be, 5 acres, whatever that, monetary value is, but your relative term would be 50%. Why? Because 5 out of 10 acres is 50% of the goods. Okay. So our fair share, right? Fair share is fair if it is worth at least 1/n of the total value of goods in the opinion of a player, where n equals the total number of players. So a fair share would mean that we all have the same amount of relative terms, right? So equal portions or proportions of total value. Now, our fair share, like I said, say there's two people, right? You want to get half of the land that's there. Say there's three people, you want to get a third of the land that's there. Say there's four people, you want a fourth. Why? Because you want one portion out of the four people that are there, right? You want one out of every player that's there. So if it was three, right, three, then we would want 1/3. If it was two people, we would want 1/2. It should make sense in that regard. So our fair is got to be greater than or equal to the total value divided by players. So, for example, Paul is one of 4 players. We know we have 4 players, right? His value, say S1, we'll call his value S1, at 12% of S. So he's player 1, right? And his share of the goods, his share of the booty is 12%, right? And S2 is 27%, whoever player 2 is. S3 is 18% of the shares, the booty, and S4 is 43% of S. Fair is greater than or equal to 25%. So you would consider fair share being more or equal to or more than 25%, right? 25% is 1/4. 25%, 1/4. So you want to make sure that if you've got more than 1/4, you have fair share. So which shares are fair to Paul as he's looking through here? Who has their fair share? Well, if we look, 25% has to be greater than or equal to that. So player 2 has a share of 27%, right? S2, share 2, player 2 share is 27%. S4 is at 43%, right? So player 4 has a greater value than 25. Player 2 has a greater value than 25, 27 and 43 respectively. But player 1 and player 2 have values of their share that are less than 25. So theirs would not be fair share, right? Only 2 that would be fair would be player 2 and player 1. Let's look at another one. So we got Joff is one of 5 players. His value is S1. He values S1 at $35, S2 at $40, S3 at $23, S4 at $22, S5 at $30. We know that fair share is going to be greater than or equal to what dollar amount, add all the dollar amounts together, and then divide by the players. So 35 plus 40 plus 23 plus 22 plus 30. So if we add all that together, we get, let's see, 75, and then we've got another 45. So 75 and 45 sit us at 120, and then 30, 150. So $150 is all the shares. Now we divide it by 5 so we can get an equal amount distributed. And so everybody's equal fair share would be $30, right? If I had $150, 5 people divided 5 waves, the fair share would have to be $30. Well, the problem here is not everybody gets $30. So which shares are fair to Jeff? Well, S1 has 35, S2 has 40, and S5 has 30. So there's your fair shares. A goal of game. What's our goal here for fair share, right? Each player gets a fair share of S. Remember that S represents the goods, whatever those goods are. S is the representation of that. So money, property, whatever. Every player wants to maximize their share of booty. Why not, right? We want to maximize our share of our treasure, okay? So here are assumptions about players. We've got rationality. Each player is thinking, rational agent seeking to maximize the share of the booty. They want to get the most amount of shares, the most amount of goods, right? Let's see, moves based on one reason alone, not emotions, not psychology, not revenge, not etc. No emotions. Don't choose something just to make somebody else mad. That would be rationality. Cooperation. Here's another thing, an assumption about a player. Cooperation. Players are willing participants and accept the rules of the game as binding. Okay, so the game will terminate to a finite number of moves, and that equals the rules. We'll get more into that in just a moment. Privacy. Each player has no useful information about other players' value systems. Symmetry. Players have equal rights in sharing the goods. At a minimum, each player is entitled to a proportional share of S. Symmetry means we want everything to be even. Okay, that one's simple. So we got to look back and we got to think about rationality, and we got to look back and we got to talk about cooperation. privacy, symmetry makes sense. So there's our 4 assumptions of players, about the players, that we can make a conclusion about depending on a couple of things like their shares, their percentages, those types of things. All right, so fair division method, right? I believe that's the entire title of the lesson, right? Fair division games. What's our fair division method? So a set of rules that define how a game is to be played. So we've got different ways that games can be played. 1, continuous. Goods are divisible. This is continuous. Goods are divisible in infinitely many ways, and shares can be increased and decreased by arbitrarily small amounts, like almost nothing. A sliver of pie, right? You guys have heard that, a sliver of pie. I just want a sliver. All right, a sliver is such a small, it's not measurable. We don't know what a sliver is. Everybody has their own idea of what a sliver is. But okay, when we think about this, we're dividing this in infinite amount of ways. Discrete. Goods are made up of indivisible objects. At a certain point, you can't break it down any smaller. It's impossible. That's discrete. Okay. Example, you can't break down a horse, right? You just can't do it. You can't break down a car. You can't break down jewelry. You can't break down intangibles, things that are tangibles. Things aren't divisible. Okay. We can't break it apart, right? If you break it, now somebody's upset. Mixed, both continuous and discrete goods, things that can be divisible and things that can't. Think about your will or your parents or your grandparents' will. A will is something that can be distributed. My sons and daughters, they have so much, right, of what I've decided to deem to them. Estate, if I own property or value in other things, all of my estate is divisible and indivisible at the same time. Okay. So there's our 3 fair division methods. We've got 4 assumptions of players. We've got 3 fair division methods. Let's look down at example 1. See what maybe all of this can come out to be. And we're almost done here. We just got this second page, and then you'll get started into something else. So example 1, Dan buys a huge cake, Dan, for $20. Half is chocolate and half is strawberry. Dan values chocolate 3 times as much as he values strawberry. Why? Because he's Dan. He likes chocolate, right? That's just what he feels. So chocolate is more valuable to Dan than strawberry. Do you feel that way? Maybe not. But that doesn't mean that it's not true to Dan. So our value fraction. Chocolate is 3 times the value of strawberry. Think about that. It's half and half. How did I come up with 3/4? If that is half chocolate, half strawberry, and he defines chocolate as 3 times the amount, we come up with 3/4 is the value fraction. Why? Because 3/4 is 3 times the amount of 1/4. Strawberry is worth 1/4, even though it's technically showing up as a half. Strawberry is worth 1/4. If you multiplied 1/4 by 3, you would get 3/4. And that's 3 times larger, so chocolate is worth 3/4. Physical fraction. So C divided by 180 degrees. Why? Because C is chocolate. Physical fraction for S strawberry divided by 180 degrees. So value fractions that you can see here, we've got chocolate is 3 times the amount of strawberry, so 3 times 1. So 3 plus 1 is 4, that's the denominator. So now you might be thinking about how I got that 3/4, right? Chocolate being 3 times the amount of strawberry. If I know strawberry is 1, let's just assume that because everything else will reduce down. Strawberry being 1, chocolate being 3, I've got 4 now. 3 over 4 is 3 times the amount. What is the value of any piece of cake? Right? How am I going to find the value of any piece of cake? Well, the sum of, say, our value of fraction times the value or the fraction of physical amount. So let's talk those two terms I decided up there, relative and absolute. Absolute was money. Relative was percentage. So if I was going to ask you to find the relative, right? This is the percentage. Percentage and fractions are the same thing. So 3/4 of, and you can't see me pointing, that's silly, 3/4 times the fraction of physical amount of C, however much we have, whatever he has, right? Plus 1/4 times the fraction of the physical amount of S. That gives us the relative term for any. The absolute terms, which is the dollar amount. Remember up here, Dan has a huge piece of cake, huge cake for 20 bucks. That's going to be the relative, right, times the total dollar amount. Let's get to that and down here in our answers. So about how much is each half of the cake worth to Dan? Well, we know that the chocolate is 3/4. We know that half of the chocolate is 180 out of 180, right? Because half of a cake, which is a circle, is 180 degrees. So 180 divided by 180 is 1. So I know that 3/4 times 1 plus 1/4 times 0. Now you might be thinking, wait a second. Why does he have 0 there in that second fraction? Well, because I'm valuing the chocolate piece of cake's worth. So if I have all chocolate and no strawberry, so 180 degrees and 0 degrees, that would be relatively 3/4 or 75%, right? 75% of the worth to Dan is chocolate. Whereas if I did the reverse, you do the same deal we just did, 3/4. Now, instead of chocolate, we have 0 degrees of chocolate, right? No pieces of cake for chocolate. So 0 out of 180. We add that to 1/4 times 180 out of 180 because all half of it is strawberry. Now 25% or 1/4 of the value in relative terms. All right, let's talk about this in absolute terms. Absolute terms, it's $20 for the huge piece of cake, right? So what is it worth to you? What would it be worth to Dan to have all of the chocolate cake, right? If you were to ask him how much you think that this is 3 times as good as strawberry, right? You paid 20 bucks for the entire piece of cake. Well, that would mean that you think that this piece of chocolate, this half of chocolate is worth 15 bucks. Why? How did he get that, right? Well, $20 is the entire total times 3/4 because that's the amount that he thinks it's worth. It's worth 3/4 of the entire cake. So that's going to come out to be 15 bucks for the chocolate. You do the same thing for the strawberry, 20 times 25% or 20 times 1/4, which gives us $5. He thinks that half of this cake, which is strawberry, is only worth $5. So if you really like strawberry, this is a steal. Go give them $5, get half of that cake. All right, easy enough. That's if we're talking half and half. What if we were to cut this into 30 degrees of chocolate and 30 degrees of strawberry? What if we cut the cake? Right now we're talking value per piece of cake. So every piece of cake is 30 degrees. So what's the value of these cakes? If I was to sell them now out piece by piece, what's the value? Well, relatively, which is relative is always thinking about this conceptually, not numeric, about like not tangible money. That's absolute. Relative is percentage. So we know that the relative is 3/4 for the chocolate. Now we know the chocolate is 30 degrees out of 180 plus 1/4 times the 30 degrees for 180 because that's the strawberry. Add those two together, and what do you get? You get a sixth. So a sixth, 1/6 of the value of this, 1/6 of the value of the entire cake is if I had a 30-degree piece of chocolate and a 30-degree piece of strawberry. So if I have both of those pieces of cake, that would be worth a sixth of the entire piece of or entire cake. So the absolute would be 20 times 1/6, which is $3.33. So if I had both of those pieces of cake, I've got $3.33. That's what I paid for it. Not that bad. So that would be talking about a huge piece of cake. I know that's confusing. Let's maybe look at another example together. So let's look at example 2 here. This is the last one from our notes. I'll modify that homework. Just make sure that you're checking that on the evaluate page or whatever the classwork page is. I can't remember. Example 2, Greg orders a pizza. Let's go back to circles, right? It's easy to cut up a circle. A third of it's Hawaiian. Pineapple pineapple needs to be on pizza. Let's just say that now. It needs to be on pizza. Pineapple's delicious. A third of it's cheese. And that's good. Just a plain slice. That's fine. A lot of people like cheese. And a third is pepperoni. I would be happy with any of these pieces of pizza. Whoever wouldn't is crazy. Greg values Hawaiian 3 times as much as he values cheese. And pepperoni 5 times as much as he values cheese. That's crazy. So let's start off with valuing each one of these and then determine where we get our numbers from. If I know that cheese is 1, Hawaiian is 3 times as much as that, and pepperoni is 5 times as much as that. 1 plus 3 plus 5 is 9. So we know that the denominator of our value fraction needs to be 9. Hopefully you followed me through that. 1 plus 3, because 3 times as much for the Hawaiian, plus 5, because 5 times as much for the pepperoni. So 9 is our denominator. So Hawaiian is 3 out of 9. That's Greg's value. Pepperoni is 5 out of 9. And cheese is 1 out of 9. Okay? So if you were to split a pepperoni, not just a pizza, circular pizza, into 3s, because you got 3 types, you just take 360 and divide it by 3, and you get 120 as the denominator for our value of the pizza. So that's where we get our, if I knew how big of a piece in degrees we got a Hawaiian, then we could take that and divide it by 120, and that would tell me, right, the physical fraction of the Hawaiian piece. All right. The value of any piece of pizza, we know that we're going to have a third for Hawaiian. Why a third? Because 3/9 reduces to a third. Times the physical fraction plus the pepperoni times the physical fraction plus the cheese times the physical fraction. That's the value of any piece of pizza that we have. Or multiple pieces. Say I got a piece. It's impossible for me to get one piece of pizza with all 3 on it. I guess unless you cut out the middle, that'd be kind of nasty. Let's not do that. You want the crust. But anyway, because I know some of you are thinking that way. If Greg wants to share the pizza with 2 other friends, he cuts 3 pieces out, right? This way, he wants everybody to have a slice of all 3. So I guess you can do it. You can do it. Look at the way he cut this pizza. Almost. There's only one person. Nope, nobody gets all 3. We get 2 types. We can get 2 types. We can get, say, pepperoni and pepperoni and Hawaiian. We can get Hawaiian and cheese, or we can get cheese and pepperoni. But you can't get all 3. So I was right. Unless you cut a giant piece. So we know that piece 1 is 40% of Hawaiian. We're just going to say this is what he cut. 40% of Hawaiian and 80% pepperoni. Piece 2 is 80% Hawaiian and 40% cheese. And piece 3 is 80% cheese and 40% pepperoni. He was trying to really all right, this is even. I'm going to cut even percentages, even angles of each type that I can get. So it's cut evenly. And this is what he ended up with. So which piece would Greg want because of the way he values everything? Well, piece 1 has Hawaiian, and Hawaiian is 3/9 value to Greg, times 40 degrees plus 120 plus 5/9 because that's pepperoni times 80 out of 120. So this fraction that we get here is 13 out of 27, right? Which that's a decent fraction right there. That's almost 50% of what he wants. It's going to be hard to beat that. Piece 2, 3/9, because he's getting 3/9, which is Hawaiian, 80 degrees of that. He's getting a ninth, which is cheese, 40 degrees of that. That turns out to be the fraction 7 out of 27. Okay. And then the piece 3, he gets pepperoni. He gets 40 degrees pepperoni. He gets 80 degrees of cheese. Again, 7/9. So which one would Greg want? Because of the way that we set this up, Greg is going to want the 13 out of 27. He's going to want piece 1 because that's greater than a third of all, right? He's getting the most value, in his opinion, with piece 1. Okay. If you've got any questions, please, please, please let me know. That's the notes. What I recommend you do at this point, if you haven't already gone through and done and my video is going to be uploaded here. If you have not done the engage, which I don't have up completely yet, do the engage and then do our notes upload because you have them now, and then do want to make sure that you're doing your notes and then do your evaluate. Okay, so that's your task now. Make sure that you do those 3 for today and you'll be good to